Hello. In this example, we're going to test for symmetry with respect to the x-axis and the y-axis. Letter A says x equals the absolute value of y. So I'm going to start out with the x-axis symmetry. For the x-axis, I'll replace y with negative y. And that gives me x equals the absolute value of negative y. Remember, the absolute value makes this positive no matter what, so this can actually give me x equals the absolute value of y. So this is the same as the original equation. Therefore, yes, this equation is symmetric with respect to the x-axis. Then we need to test for y-axis symmetry. For y-axis symmetry, I replace x with negative x. Unfortunately, there's nothing I can do here, because even if I divide by -1, that doesn't make this the same as the original equation. Therefore, it is not symmetric with respect to the y-axis. And you can see this if you see that this is actually the absolute value just opening towards the right. Notice that it's not a function and it's not symmetric with respect to the y-axis. Now let's look at B. B is y equals the absolute value of x minus 3. This, if I'm testing for the x-axis, I'll replace the y with negative y. When I do that, that gives me negative y is equal to the absolute value of x minus 3. This, I can't do anything with it, therefore it's not the same as the original. Even if I divide by -1, that gives me y equals negative absolute value of x plus 3, which again would not be the same as the original equation. Therefore, no, this is not symmetric with respect to the x-axis. Then we need to look for y-axis symmetry. And again, we replace the x with negative x, and that gives me y is equal to the absolute value of negative x minus 3. Again, because it's the absolute value of negative x, that makes this y equals x minus 3. The absolute value of x minus 3. This is the same as the original equation. Therefore, it is symmetric with respect to the y-axis. This can be seen if you graph this. This is the absolute value shifted downward. Therefore, it's symmetric with respect to the y-axis, but not the x-axis. Now, let's move on to letter C. C is 2x minus y equals 6. We're going to start out with the x-axis symmetry, so that gives me 2x minus negative y is equal to 6. Minus and negative is positive, therefore it's 2x plus y equals 6. Notice this is not the same as the original equation. Therefore, no, this is not symmetric with respect to the x-axis. Now let's look at the y-axis. Replace the x with negative x this time, so that gives me 2 times negative x minus y is equal to 6. So 2 times negative x is negative 2x minus y equals 6. And this is not the same as the original. Even if I divided by a negative, that would give me 2x plus y equals negative 6. And this is not the same as the original either. Therefore, this is not symmetric with respect to the y-axis. And again, you could see this. This is actually a linear equation, and it would look like this. Notice it's not symmetric with respect to the y-axis, and it's not symmetric with respect to the x-axis. Let's look at letter D. Letter D is x squared plus y squared equals 25. First, I'm going to test for the x-axis symmetry, which means I need to replace the y with negative y, and that gives me x squared plus a negative y squared is equal to 25. And whenever I simplify, that gives me x squared plus y squared equals 25. Notice this is the same as the original equation, therefore, yes, this is symmetric with respect to the x-axis. Now if I test for y-axis symmetry, I replace the x with negative x and simplify. Therefore, whenever I simplify, I get again x squared plus y squared equals 25. And notice this is the same as the original equation, so again, this is symmetric with respect to the y-axis. And the reason this happens is because this is a circle centered at the origin of radius 5.